if you look, we have the same chart as before from our formula sheet, just sort of zoomed in, and you can compare that to the table that we built ourselves, and we can even add 10 to the 0 like it has up there. And of course, that's just a standard. We have 10 to the 1, 10 to the 0, then 10 to the negative 1. You can see that's kind of how this chart works. We have the biggest over here. It goes up to get smaller, and then it sort of parabola, or makes this parabola shape back downward to get even smaller than that. And it works the exact same way backwards, going this way. But what I want to talk about in this video is how to use the prefixes in this chart, sort of what those prefixes are and how and why we use them. So let's start with something simple. Let's start with kilo. So let's say we have 1 kilogram and we want to convert it into the standard, which of course would just be grams. Well, this is kind of obvious. 1 kilo is 1,000. It's 10 to the third. If you look at your chart, we're going from kilo to the standard. That's 10 to the third grams. And of course, that third exponent, or the exponent to the that is 3 to the third power, that just means move this decimal 3 places to the right, which means we get 1,000 grams. That's just another way to write the same thing. And so what's going on? Well, we're just using our prefix to convert it to the standard, because that's what we asked. And we're using what that prefix means as a way to sort of compare it by looking at our table. And so this is true for any kilo, for any unit, using these prefixes. So it's true for bytes, it's true for liters, it's true for tons. So let's show that. Let's say instead of a kilogram, let's say we have 1 kilometer or 1 kilometer. Well, if we want to convert that to the standard, well, that would just be meters, just without the kilo in front of it. Well, it works the exact same way. It's just 10 to the third meters, which is, of course, the same thing as saying move that decimal place 3 places to the right, which means 1 kilometer is 1,000 meters. And if that seems way too simple, I'm doing that on purpose. I'm sort of showing you something that that's sort of general knowledge. Starting simple to prove it true, and then show you how you can use this chart to your advantage. And so we can actually work backwards. We can do the exact same thing. We could say 1 gram. Let's say we want to convert that from the standard into kilograms, so the kilo version. Well, if you look, it's kind of the same thing. We're still using that exponent to the third power, or we're still moving that decimal place, or 3 places. But here it's working backwards, so we do the backwards version, which is 10 to the negative 3 kilograms, or of course, we'd move that decimal place 3 places, and we get 0.001 kilograms. And if you're asking yourself, why would we ever convert the standard into the kilo version of the unit? Well, let's look at a more practical example here. Let's say we wanted to convert 1,200 meters into kilometers. Well, we'd follow the exact same rule. We'd take that decimal like we did here, and we'd move it 3 places to the left, because that's what our chart says to do. And so we get 1.2 kilometers. And so you can see, you just sort of look at the exponent, you look at how many places the decimal moves using your chart, and you can just sort of figure it out. And the same rules that apply to the right side apply to the left side. So we can use milli, for example. We could say, well, what is 1 millimeter into meters? Well, okay, well, we just take that 10 to the negative 3 again. So we'd say 10 to the negative 3, and we're moving in the same direction as if we did 10 to the third to the standard. As we go this way, we're going to the right, and then again, we're going to the right. We went to the right up here, so we're using the same exponent. Well, that makes sense. And so since it's going in the same direction through our chart, we would move the decimal the same direction as well. We'd get 0.001 meters. And then, of course, just like before, we do the exact same thing going backwards. We'd say 1 meter equals how many millimeters? Well, that's just 10 to the positive third millimeters, or 1,000 meters. I'm sorry, 1,000 millimeters. And then, of course, the same thing would be true if we did centi instead of milli. We'd use 2 instead of 3. So we could say that. We could say, well, what's 1 centimeter converted to the standard, which would be meters in this case. Of course, if we use centigrams or centiliters or anything else, it would all work the same. But we would say 10 to the negative 2 would follow the same pattern. We just use the different exponent because it is a different exponent. And then we can rewrite that as 0.01 meters. And of course, again, it works the exact same going backwards. 1 meter is how many centimeters? Well, we know, hopefully by now, it's 10 squared centimeters because look at the direction it's going and what the exponent is, or just sort of write 100 centimeters. And so if it's not obvious yet why we use prefixes, let me see if I can show you a more extreme example. What if I said I had 1 gigabyte of memory? So 1 gigabyte of memory. Well, if we wanted to convert that to the standard, which would just be regular bytes, what we would say is that's the same thing as saying 10 to the 9th bytes, or we could rewrite that as, well, 1 with 9 zeros after it, or in other words, 1 billion bytes. So why do we have prefixes? Why do we use this system, and why do we use this chart to convert? Well, hopefully at this point, it's incredibly obvious why we use these prefixes. The reason we use prefixes is simply, it makes our lives easier. And let me show you how it makes our lives easier. Let's say I had 120 billion bytes, just like we had before. This time we have 120 billion. Let's say my Xbox has 120 billion bytes on it, and I had to write that out. Well, of course, if we all agree what giga means, well, we could just say this is the same thing as saying, actually, I'm not even going to do the equal sign. I'm going to just draw a big arrow. It's a lot easier to say just 120 gigabytes. And then, of course, the same thing is true for our negative exponents. We could say, instead of saying I measured something out and I got 0.0025 meters. Well, I don't even know what those little decimals means. What is that? Well, we could rewrite that by converting it into, let's say, millimeters. So we move that decimal place 3 places to the right because that's what it says to do. It's 10 to the negative 3. We'd say, well, that's 2.5 millimeters. Or what if we don't like millimeters? We can convert it to centimeters instead. So instead we move it 2 places to the right because 10 to the negative 2. And so we just say 0.25 centimeters. And that's sort of why we use prefixes.